Hello everyone, welcome to the next chapter. In this chapter, we shall explore heat transfer analysis in a shell and tube heat exchanger. What is a shell and tube heat exchanger? This is a type of heat exchanger which is commonly used in many industrial applications to transfer heat between two fluids without mixing. We shall see the diagram here. Here, one fluid enters the tube side and the other fluid enters the shell side. Here, both the fluids are at different temperatures and heat transfer occurs in the shell and tube region. We can see in this image the fluid at high temperature represented by red color is entering the tube inlet here and it passes through the series of tubes and leaves at the left end. On the other side, the second fluid enters through the shell side, that is from the shell inlet. It goes around the tubes and leaves the heat exchanger from the shell outlet. The fluid which is entering the shell is at a lower temperature and is represented by blue color. We can see the temperature changes through the color variation. Here both the fluids are at a different temperature and heat transfer occurs in the shell and tube region. Let us see the components of shell and tube heat exchanger. The first one is shell. This represents the outer container that holds the tube bundles and also carries one of the fluid. It forms the main central casing part. The next is tubes. These are a series of small diameter tubes which flow inside the shell and carries the second type of fluid. The next is tube sheets. These are the tube holding plates which are kept at both the ends of the tubes. The fourth one is baffles. These are metal plates inside the shell which directs the flow across the tubes to improve the heat transfer. So baffles are shown here. These are all vertical plates inside the shell region. And finally we have heads or end caps which are attached to the ends of the shell and it directs the tube side fluid flow. Here heat transfer occurs through the walls of the tubes and in general hot fluid passes through the shell side. Okay, with this introduction we shall see some of the industrial shell and tube heat exchangers. Some images are given here. The size and number of tubes vary depending on the level of application. More the number of tubes, more will be the surface area and higher will be the heat transfer rate. Following this, we will see the types of shell and tube heat exchangers. The first category is based on flow direction. When both the cold flow and hot flow are in same direction, it is called parallel flow heat exchanger. If the directions are opposite, then it is counter flow heat exchanger. In both cases, we can see the variation of temperature profile. Here the high temperature fluid temperature drops and the low temperature fluid temperature increases. Similarly in the counter flow. Next we can categorize based on the number of pass. For example, in the first case, we can see there is one shell pass and two tube passes. That is, the tube has a U-bend here and there are two passes. In the next image, we can see there are two shell passes and four tube passes. Okay. These are some of the types of shell and tube heat exchangers. Moving on, we shall see what is log mean temperature difference, that is LMTD. Here the temperature profile of the hot fluid and cold fluid is given for both parallel flow and counter flow heat exchangers. The uppercase T represents the temperature of hot fluid for both cases and the lowercase represents the temperature of cold fluid. And the plane 1 represents the left side region and the plane 2 represents the right side region. Cut, start. And plane 1 represents the left end and plane 2 the right end. Here theta 1 represents the difference in temperatures in the left end for both cases, that is T1 minus T1, that is uppercase T1 minus lowercase T1. Similarly, theta 2 represents the temperature difference at the other end, that is uppercase T2 minus lowercase T2. Then log mean temperature difference, that is delta theta, is given by theta 1 minus theta 2 divided by ln of theta 1 by theta 2. This formula we have to remember to find out log mean temperature difference of any given heat exchangers. Okay, with this information we shall go ahead to the problem definition. You can see the CAD model here. The shell and tube are separately shown here. This problem will be having two domains. One is the shell domain and the other one is the tube domain. We shall give corresponding interfaces at the common regions. The rough sketch of the model is shown. There are 7 tubes in this model and the dimensions are given here. We shall create this CAD model in Design Modeler and do the analysis in Ansys CFX. Okay, in the next lecture we shall create the CAD model. I will see you there.